So let us start. So we have question 3. Something important to take note of whenever you start with an analytical geometry question, always read the above information that is below the question and take a few minutes to actually go through the diagram itself. That'll give you more insight and more information into the question. So we have question 3 that states, in the diagram, A, which has coordinates -2 and 2, B, which has coordinates 6 and 5, C, which has coordinates 0 and -3, and D, which has coordinates X and Y. So based on that, we can see that the coordinates of D are unknown. Are the vertices of a quadrilateral having AD parallel to BC. So if you went through the formula sheet that I shared in the group, you should know, based on the property of parallel lines, it means that the gradient of AD is parallel to the gradient of BC. Sorry, is equal to the gradient of BC because the lines are parallel. We then have BA produced has an x-intercept at E. Something important to take note of is that an x-intercept is where the line or the curve cuts the x-axis, meaning that the y value is 0. And that is at point E. We then have ED and AC intersect at M. N, which has coordinates T and 0, so the X value of N is unknown, is a point on AD. Okay, so let us take a moment to look at our graph. We can see that AD and BC are parallel. It was stated in the information. We can see that we have x-intercepts at E, N, and this point on the right that is not given. We can see that C is a y-intercept, and we can see that D does not have a coordinate. Okay, so let us look at our first question. Question 3.1 states, calculate the gradient of BC. So we have multiple methods of calculating gradient. The first and most common method is to use the formula m equals y2 minus y1 over x2 minus x1. That is our most used or most frequently used formula. Secondly, we have m equals tan theta, whereby theta represents the angle between our line and our horizontal. Thirdly, we have the gradient of parallel lines, which are equal. So if the gradient of one line is known, we can therefore determine the gradient of the second line, provided that both lines are parallel. And fourthly, we have perpendicular lines. If the lines are perpendicular, meaning that they meet at an angle of 90 degrees, we then know that the product of their gradient is equal to -1. So those are the methods that we can make use of to calculate gradient. So let us try to determine which particular method are we going to use for this question. So I'll repeat the question once more. Question 3.1, calculate the gradient of BC. So our line BC, let me highlight the line so you can see which line we are referring to. So BC, we can see that we have the coordinates of B and we have the coordinates of C. So we are going to use the first method. We only use the first method if both coordinates are known, and it does not have to be the ending coordinates of the line. if the middle coordinate was given, say for example, we had this coordinate as 4 and 1. We could have used the coordinate of B and this coordinate. The main goal of this is to use two coordinates that are on the line. It does not have to be the ending points or the middle points. It does not matter as long as it is two coordinates on the line. Before we get to that question, just allow me a moment. There is a question in the group, in the chats. Okay, the student that says you cannot hear me properly, did you change over to speaker instead of using your cell phone's audio? I would recommend for students that have just entered the class, your cell phone's audio is set up so that it is at a lower volume. If you cannot hear me clearly, I recommend changing it over to speaker, which will then magnify the volume. I am sick, I've got the flu, so I cannot speak any louder than I already am. So I would recommend you change over to speaker. New students, how to change over to speaker. If you are using a cell phone, at the bottom of your device, there are 5 options. If you look the furthest to the right, you will see a red button. That's the leave option. If you go to the next option, you'll see 3 dots. One more option to the left is an audio option. That looks like a speaker basically. Click on that speaker. Once you've clicked on the speaker, 3 options will pop up. Those 3 options are device, speaker, and no audio. Click on speaker. That converts the Microsoft Teams audio from your cell phone to a speaker option, which will magnify the volume and will allow you to hear me properly. Okay, I'm not going to talk any louder than I already am. It's up to you to change over from device to speaker. I'll repeat it once more. There are 5 options at the bottom of your screen. The red button, to the left of that, there's 3 dots. To the left of that is a speaker option. So all you need to do is click on the speaker button and change from device to speaker. There must be a tick next to speaker. If there's a tick next to speaker, then it should be fine. And make sure that your cell phone, if you are using a cell phone, there's an increased volume and a decreased volume. If you're not aware, make sure that you press on the up one, the up button, that's to increase your volume. If you are using a laptop, that feature is not available to you. You just have to increase the volume on your laptop. Okay. Yeah, so let us proceed. So we needed to now calculate the gradient BC. In order for us to calculate the gradient BC, as I previously mentioned, you are going to use the formula M equals change in Y over change in X. I know some students prefer to use 1 minus 2 or 2 minus 1. It doesn't matter which you use as long as it's consistent. You can't use x1 minus x2 and at the bottom swap it over, use 2 minus 1. If you use 1 minus 2 at the bottom, you also have to use 1 minus 2. Keep that in mind when doing gradient questions. So our first question is 3.1. We need to calculate the gradient of BC. So as you can see to the left of your screen, you've got BC. So our gradient formula is y2 minus y1 over x2 minus x1. You can also use one minus 2, it doesn't matter. From that point, because we are calculating the gradient of BC, I'm going to use the coordinates of BC. So I'm going to write that down. So we have 6 and 5, as well as 0 and -3. That then becomes x1, y1, x2, y2. Okay. A student that was able to successfully transfer over from your device to your speaker, can you please send a screenshot of that in the group? That way it can assist students that are struggling with the concept. Okay, so from this point, because we've now indicated which is 1 and 2, you could have just as easily used 0 and -3 as your 1 points. It doesn't matter which you use as long as you are consistent with it, okay? So from that point, you can substitute. So y2, I've indicated -3 as y2. Now I need my y1 value. That is 5. Next, I need my x2 value, which is 0, and my x1 value, which is 6. From there, you can put that into your calculator. So you should end up with +4/3. Now that is the gradient of line BC. One more thing to take note of, if this is your first time using Teams, another feature that is available to you is to slide your notification bar down and click on auto rotate. If you click on that, if you rotate your cell phone, you'll see that your screen will become enlarged, and I feel like that's a better view to look at as opposed to the horizontal or the portrait view. So to repeat once more, slide your notification bar down, click on auto rotate. That's the options that are there by your mobile data, your Wi-Fi options, your torch options, your Bluetooth, your screen brightness. Click on auto rotate and then rotate your device. That will allow you to view an enlarged picture or an enlarged whiteboard. Okay. So we've now calculated question 3.1 to only calculate the gradient of BC. Let's move on to question 3.2. Determine the equation AD. So if we want to determine the equation AD, in order to determine the equation of a straight line, we need two things. We need the gradient of that straight line, and we need a coordinate on that line. So if you take note of the line AD, you can see that D has X and Y, so we cannot use that. Whereas A has -2 and, okay, just give me a moment. Hi, sir. Will it just be 4/3 or 4/3 units? Okay, so gradient, you don't need to put a unit. If you want to specify units, write the word units. You can if you want to, but technically you don't have to. Remember, gradient is just basically a ratio. It refers to the horizontal level. Basically, it refers to the distance over the rise, or rise over distance, whichever you want to look at it. So based on that, you don't need to include a unit of measurement. You can just leave your answer unitless because this is a ratio. So to repeat once more, gradient is a ratio, so you do not need to include a unit of measurement. Okay, so to go back to what we were doing, 3.2, determine the equation of AD. So in order to determine the equation of a straight line, you need two things. You need a coordinate on that line, and you need the gradient of that particular line. So we have one thing just by looking without thinking or without any further in-depth thought, we can already see that we meet one of the criteria. We have the coordinate on that line, which is point A. Point A is on the line AD, therefore we have the coordinate. Now the second criteria that we need the gradient AD. How do we find the gradient AD? When we do not have the coordinate D, therefore we cannot use our traditional method of calculating gradient. If you go back to the formula sheet that I sent earlier, you'll see one of the options refers to parallel gradients. Whenever gradient is parallel, whenever the lines are parallel, the gradients are equal. So let us attempt question 3.2. So 3.2, we need to get the equation of a straight line in the form y equals mx plus c. So we have the value of x, we have the value of y. It's -2 and 2. How do we get gradient? That is obtained using the property of parallel lines. So because line BC is parallel to AD, that then means that the gradient of AD is equal to the gradient of BC. And we previously calculated it as 4/3. I would recommend you use the subscript BC or AD or whatever the line is. The reason that I prefer to use the subscript is in most cases, especially with analytical geometry, the questions or the answers that are previously calculated are usually used in the next or the following questions. So especially when you are in an exam setting, you're under pressure, time is limited, you're stressed out, maybe you didn't sleep nicely last night, whatever the case is. If you just write m equals 4/3, you're going to spend extra time trying to look for the gradient. Whereas if you wrote the subscript BC, if you wrote the gradient of BC, MBC, automatically you just look up, you can see, oh, I previously calculated it. So that is a reason that I would recommend that you use the subscript. It's important, okay? So let us proceed with the question. We've now determined that the gradient of AD is the exact same gradient as BC due to the fact that those two lines are parallel. We also know that the line AD has a coordinate on it, which I believe was -2 and 2. Yes. So we have that x value, right? -2 and 2. So all we now need to do is substitute that coordinate and substitute the gradient into this formula in order for us to get the C value. Once we find the C value, we can therefore substitute only the gradient and the C value into this equation, and we are done. Another important thing to take note of is that if you are already given the C value, you do not need to use this long process. All you need to do is substitute gradient, substitute the C value, and you are done. If you are given the C value, it's shorter, it's easier. There's not a lot of hard work involved. Just substitute M, substitute C, and you are done. Now, what is the C value? How do you even know if you are given the C value? So our C value, or the C value in particular or in general, refers to the y-intercept. The y value of the y-intercept of that line is the C value. So if this line AD cut the y-axis at, let's say, 7, our C value would be 7, okay? And you just need to substitute if it was given to us. So let's say the reason I'm going with 7 is because it looks like it will cut higher as opposed to this one. So C looks like a particularly nice estimate, or 7 rather. So in this case, C would be 7 if the line cut the y-axis and they gave you that value. So there was a point here, 7. Or if it was written as a coordinate, 0 and 7. Automatically, all you do is substitute your gradient and substitute C equals 7 and you're done. There's no extra hard work. But in this case, because we are not given that value of C, we now need to go and calculate it. So we need to do the extra work in order to calculate it. Okay. So this is going to be 2 equals, because remember, this is our y value, right? This is y as 2, x as -2. So substitute y as 2, substitute your gradient as 4/3, and substitute your x value, which is -2 plus c. Our whole goal of this is to find our value of c. From here, we have 2 equals -8/3 plus c. From there, all we now need to do is move -8/3 to the left and add up the left-hand side, and that will give us our value of C. So something important to take note of is that when we move a negative value, it will become a positive value. So -8/3 on the right will then become +8/3 on the left, and that is equal to C. From there, we can put this into our calculator. So in your calculator, you'll have 2. Just give me a moment. Okay, so you'll have 2 plus 8/3, and that will give you 14.67. Now, I would recommend you leave your answer in a fraction form as opposed to leaving it in a decimal form. It's more accurate in a fraction as opposed to a decimal, because in a decimal form, you have to round off. Okay, so our value of C is therefore 14/3. So we can then conclude that our equation of this straight line AD is therefore equal to, now like I mentioned previously, we are only going to substitute the gradient, which is 4/3, and we are going to substitute the C value, which is 14/3. That's it. That is our equation of the straight line AD. All we needed was to find our value of C by substituting our gradient, our x value, and our y value. That allowed us to obtain C. Once we've obtained C, we were then able to substitute our gradient and our constant and our C value. Okay. Now, the students that are struggling or that are not clear on how we found gradient, keep in mind that the line BC is parallel to the line AD. Because those lines are parallel, it means that they have equal gradients. Does it make sense? Okay, so just allow me a moment to send a screenshot into the group for those that are still struggling and are unable to hear me. That way they can also change their settings over to speaker as opposed to device. Oh, okay, never mind. I see someone did that already. Okay, Somdala, thank you so much for assisting. Perfect. Okay, so let us proceed. Guys, if you are struggling or if you're confused about something as I'm proceeding with the questions, you are welcome to unmute yourself, speak up and ask. It's an online platform, so 90%, there's a 90% chance that no one here knows who you are. So there's no reason to feel shy, no reason to feel scared. No one's going to laugh at you. No one's going to make fun of you. You're welcome to speak up and ask. There was someone that said, "Sir, do you have a question?"
Yes, I do.
What's your question?
So my question is that we have the formula which is y equals to mx plus c. So because we have already calculated the gradient, so we substitute m by 4/3.
Yes, because we already obtained the gradient, we did not need to recalculate the gradient. It was already calculated previously. The only thing that we needed to do, maybe in most cases, depending on the memo, sometimes it can be awarded 1 mark. If you indicate that the lines are parallel, therefore they have the same gradients. Because if you look at the question, do you see, let me highlight it for you. So I'm going to highlight it in yellow. So line AD and line BC. Do you see this arrows here that indicates that they parallel? Because those lines are parallel, it means that their gradients are equal. So the gradient of AD is equal to the gradient of BC based on the fact that the line AD is parallel to BC. Okay, does it make sense?
Yes, does.
Perfect. Okay. Excuse me. What if the lines were perpendicular? Okay, so if the lines were perpendicular, they would not be equal. So if your lines were perpendicular, it would mean that the product of their gradients is equal to -1. What I mean by that is the gradient of the first line times the gradient of the second line would be equal, would be equal to -1. Let's do a quick example. So if this is AD, actually the gradient was positive, so let's make that BC. Tyler, I see your hand up. I will assist you in a moment. Okay, so let's state this is the situation. We've got BC perpendicular to AD, okay? Students that do not understand the concept of perpendicularity, if something is perpendicular, it means that they meet at an angle of 90 degrees. A nice example of that is your house or your door. Look at your door. Your door is at an angle of 90 degrees to your house or to the walls. To the floor, I mean, sorry. Your door is at a 90-degree angle to your floor. The wall is at a 90-degree angle to the floor. If your house was not at a 90-degree angle to the floor, your house would fall over eventually after a few weeks or whatever. Okay, so yeah. So if these two lines were stated as perpendicular, right? Because we've previously calculated the gradient of BC as equal to 4/3, if we wanted to find the gradient AD, all we would need to do is use the formula that I shared with you in the PDF I shared in the group. It states that the product of their gradients is equal to -1. We know that MBC is 4/3, so we'd substitute. Both sides you can divide by 4/3, or you can multiply, then divide, or cross multiply, then divide. Whichever algebraic method you prefer to use, you can do that. So if you were to divide, that would then be divide, let's swap over, just give me a second. Okay, so -1 divided by 4/3. That'll then give us -3/4. So if these two lines were perpendicular, our gradient would be -3/4. How we would find that -3/4 is by multiplying the gradients of the two lines that are perpendicular to one another and making that equal to -1. And then we solve for the unknown gradient. Something that I've seen quite often is a question that states show or prove that the lines are perpendicular. If they ask you to show or prove that the lines are perpendicular, all you would need to do is multiply the two gradients. So if they're asking you to show, it means most likely both gradients are given. So just use this formula that I'm going to highlight. This is the formula, right? Substitute both gradients. Don't make it equal to -1 if you are showing, right? So basically all you would do is this. You'd say MAD times MBC and substitute. 4/3 times -3/4, and that gives you -1. That is showing or proving that they are perpendicular. Then you'll state, therefore, AD is perpendicular to BC. So that is the approach that we would take if these two lines were perpendicular. However, in the particular question that we were dealing with, those two lines were parallel, not perpendicular. Okay. So just give me a moment to clear this up, and then we will proceed with 3.3. Okay, so we have question 3.3 that states determine the value of t. Now, if you think back to when we first started the class, I mentioned that t is the x value of point n. So here it is if you want to have a look. We've got the coordinate n, which has coordinates t and 0. So our value t is the x value of n. Now, how do we find the x value of n? Let us first locate n on our graph. So if you notice, n is the x-intercept of AD. Now, something important to take note of. Because it's on the line AD, we can use the equation of AD to calculate the x value of n. So if you got the previous question wrong, chances are the next one will be wrong. So it is extremely important when you are dealing with analytical geometry is to make sure that double check each question. If you started off with question 3.1 wrong, that means 3.2 will be wrong, 3.3 will be wrong, 3.4 will be wrong, and so on. You've basically wasted half an hour of your time to answer question 3 because everything would be wrong. So always make sure that you double check the questions and the answers, okay? Because in analytical geometry, most of the time, the previous questions are used to answer the following questions. So we now need to calculate the coordinate of n, or more specifically, the x coordinate of n, using the line AD. The reason that we are using the line AD is because point N is on the line AD. Before we proceed, I forgot, Tyler, you previously had your hand up. What was your question?
I wanted to ask if the question doesn't have the parallel lines, what happens in that case?
So in your question, if it's not parallel, is it perpendicular, or are there coordinates given? Is there an angle given? Or is it collinear?
Coordinates are given.
Your coordinates are given. So
Yes.
if the coordinates are given, let's say, for example, we needed to calculate the gradient of AD, right?
All right.
And if the lines are not parallel, if they're not perpendicular, if they're not collinear, and if there isn't an angle given, it means that two coordinates on the line AD were supposed to have been given. For example, we could have been given both x and y values of n, or both x and y values of d. If it's not collinear, if it's not parallel, if it's not perpendicular, and if there's not an angle given, you must have two coordinates on that line in order to calculate the gradient of that line. Does it make sense?
Yes,
Okay.
thank you.
Sure. Okay, so let us proceed. We were busy with 3.3. We needed to calculate the x value of n, which is a point on the line AD. If you want to calculate a point or the coordinates of a point on a line, all you need to do is substitute one of those points into the equation of the line, and it will give you the corresponding x or y value. So if you have the x value, all you need to do is substitute that x value into the line AD, and it will give you the corresponding y value. If you have the y value, as is the case with n, all you need to do is substitute that y value into the equation AD, and that will give you the corresponding x value. So that is the method and the approach that we will take to find t, which is the x value of n. So we previously found the equation AD. So all we are now going to do is substitute into the equation. So y of AD is equal to 4 over 3 x plus 14 over 3. Okay, and we are going to use the coordinates t and 0. So in place of x, we are going to substitute t. In place of y, we are going to substitute 0. And then we are going to solve for t. So in place of y, we substitute 0. In place of x, we are going to substitute t. And now we need to solve for t. So what I'm going to do is I'm going to move 4 over 3t to the left. So that's going to become negative 4t over 3 equals 14 over 3. Now, there's a few options that you can use depending on your preference. You can either divide both sides by negative 4 over 3, which I feel is the fastest approach. Alternatively, you can cross multiply, then divide, which I feel is a longer approach. Yeah, those are basically the approaches that you can take. So what I'll do is I'll use both approaches, and you can see which you prefer, and that will be the method you can progress with. So I'm going to start off with the method whereby we divide both sides by negative 4 over 3. The reason that we are allowed to divide by negative 4 over 3 because negative 4 over 3 is considered the coefficient of our variable. Whatever is in front of your variable, even if it is a fraction, it is still considered the coefficient. Because consider this, negative 4 over 3t, you can write it separately. That would be your coefficient. Okay, so that is why you are able to divide by negative 4 over 3. So if we divide by negative 4 over 3 on both sides, on the left, negative 4 over 3 will cancel each other out. And on the right, 14 over 3 divided by negative 4 over 3 will then give us a value of negative 7 over 2. So we can state, therefore, t equals negative 7 over 2, and that is our value of t. Now, if you preferred to take the alternative approach whereby you cross multiplied then divided, this is what your sum would have looked like. So you would have first cross multiplied. So 3 times the left side would have been minus 4 times 3 T equals then the 3 on the left times the 14 on the right. And that would have given you negative 12. T equals 14, 28, 32, 42. Now from here, so that is just the cross multiplying part. From here, all you need to do is divide both sides by negative 12. Because that is your coefficient of t. So negative 12 divided by negative 12 would cancel out on the left. And you can therefore state t equals then 42 divided by negative 12. Just give me a moment. That would have given you negative 7/2. So irrespective of which method you use, you will end up at the exact same value. Okay. So let us proceed. So we now have question 3.4. Question 3.4 states, calculate the length AN. So let's first go and find AN. Okay, here is AN. Let me highlight it. So we need to now find the length AN, keeping in mind that A length refers to distance. So if you look at the formula sheet that I gave you, that is the very first formula, the distance formula, that is length. Okay. So let us now go and calculate for the length or the distance of AN, keeping in mind that in order to calculate distance of AN, this is not the same as gradient. You can't use any points on the line. You have to use the end points of that specific line. So because they stated length AN, it means you have to use coordinates A and N because those are the ending points of the line AN. If they told you calculate the length AD, you would use coordinates A and D. It is not the same as gradient whereby you can calculate using any points on the line. You have to use the ending points that will give you length or distance. Okay, so question 3.4. So we now need to calculate the length AN, which is question 3.4. So if we want to calculate the length AN, we know that we are given the coordinates A, which is -2 and 2, and N, which we previously calculated as, I believe, -7/2. Was it negative or positive? It was negative. So -7/2 and 0. Now, our distance formula is D equals the root of x1 minus x2 squared plus y1 minus y2 squared. Okay, now I'm going to make A my 1 values and N my 2 values. So from there, all I'm going to do is substitute into the formula. So because I'm calculating the length AN, in place of D, I'm going to put AN. Okay. Now, from here, always remember you need to bring down the root sign. Don't leave out the root sign because that will affect your final answer. So bring down your root sign. Substitute x1 is -2 minus x2 is negative 7 over 2. So I'm going to make this a squared bracket instead of a rounded one. Negative 7 over 2. Something important to take note of, I've seen this error quite a number of times, whereby because there's a negative in the formula and because the value is negative, students then leave out one of the negative signs. So instead of writing negative negative, they would have negative 2 minus 7 over 2. That is wrong, and that will give you an incorrect final answer. Always bring down the negative from the formula, then open a bracket and put the value that has a negative sign. Do not leave out one of the negative signs because the formula has a negative sign, okay? Now, go to the y values. Y1 is given as 2 minus y2, which is given as 0. Then we can complete our root sign. Now, from there, an is equal to the root of, instead of even putting the root, from this point, we can just put the entire right-hand side onto our calculator. We do not need to calculate each individual component. That's just a waste of time. What you can do is put the entire right-hand side onto your calculator and it'll give you 5 over 2. Or you can have 2.5, whichever you want to. Now, because distance is not a ratio, you can put units. If you leave out units, it doesn't matter. It's fine. But yeah, if you want to put it, you can put it. Doesn't really matter. You won't receive an extra mark. You won't be penalized the mark. You'll get the same marks as someone who left it out or someone who didn't leave it out. So what I would suggest is, because the right-hand side is slightly complicated, meaning that it has a lot of square roots or squared values, I would recommend putting it into your calculator twice. So put it the first time, see what answer you get. Clear your calculator, put it the second time, and see if you get the exact same value. If you get the same value, then it is correct, move on. In a lot of cases, because we are rushing in an exam situation and because the right-hand side is slightly complicated in its presentation, we can therefore make slight errors. Especially if you have big fingers and a small calculator, you can maybe press the wrong button by mistake or 2 buttons by mistake. So always double check. And something else that's important, make sure that your calculator is on the correct mode, meaning that if you are using a Casio calculator, on top you should see a D for decimal. Make sure it is on that mode, okay? If your calculator is on radians or another mode, it's going to give you an incorrect answer no matter how many times you put it into your calculator. So please keep that in mind. Okay, so let us move on to question 3.5. So we have question 3.5 that states, if DC is defined by y equals 3 over 8x minus 3, determine the coordinates of D. So we are now given an equation for DC. So we go up to our diagram. Where is DC? Okay, DC is at the bottom of our diagram. It is the yellow line that I have highlighted. Excuse me. So point D, point C, something important to take note of is that point C is a y-intercept. And as you can see, because it's a y-intercept, the equation of DC, your C value will be -3, meaning that the constant in your equation will be -3. If we go to our equation, you can see it is -3. So if we were asked to find the equation of DC and we were given the gradient, or we were given some way to calculate the gradient, it would be easier than question 3.2, because all we would need to do is substitute gradient, substitute the C value, okay? But back to our original question. Our question stated if DC is defined by that equation, determine the coordinates of D. So this is basically, or this is not the same, but it is similar to the previous question whereby we calculated 3.3. Once again, we need to calculate a coordinate. But in this particular question, we're going to use a method that is slightly different. The reason being is that in question 3.3, whereby we calculated the x value of coordinate n, we were given one of the values. We were given the y value, which allowed us to substitute that y value into the equation to obtain an x value. And the opposite is also true. But in this particular case, we are not given an x value and we are not given a y value. So we cannot use the same method. But what a method that we can use is we can use simultaneous equations. So simultaneous equations is, I'm sure, something you've come across already in term 1 under algebra. The reason that we can use simultaneous equations is because if you notice, point D is a coordinate on the line AD and a coordinate on the line DC. So because that one point occupies a space on two lines, we can use simultaneous equations to solve for x and y. So my two equations are going to be the equation of AD and the equation of DC. So let us go back and find the equation of AD so we can use it. Okay, see, it makes things so much easier because I've used subscript AD. I didn't have to search frantically for it. I was able to straight away go and identify equation AD, which is 4 over 3x plus 14 over 3. And the equation of DC, which is 3 over 8x minus 3. So what I'm going to do is I'm going to equate both those equations because they have the same y value and the same x value. So this is 3.5. My first equation, y of AD, is equal to, it was 4 over 3, not 14. 4 over 3x plus 14 over 3. And my second equation, y of DC, is equal to 3 over 8 x minus 3. Let us confirm if it's 3 over 8 or 8 over 3. It is 3 over 8. Okay. Now, because my point D occupies a space on both AD and DC, we then know that the y values and the x values of that point are going to be the same. Therefore, y of AD is equal to y of DC. Now we can substitute those equations in its place. 4 over 3x plus 14 over 3 is equal to 3 over 8x minus 3. From here, I'm going to move all of the variables and their coefficients to the left-hand side and all of the constants to the right-hand side. So that is going to be 4 over 3x minus 3 over 8x equals minus 3 minus 14 over 3. Now on your calculator, always remember when you are adding up the coefficients of like terms, all you need to do is add up the coefficients on your calculator because you know you can't put x onto your calculator. So you'll just put 14 over 3 minus 3 over 8, and that'll give us 100. Sorry, it's not 14 over 3, it's 4 over 3. And that'll give us 23 over 24x. Which is then equal to, now we're going to put the right-hand side onto our calculator and see what value it gives us. So minus 3 or negative 3 minus 14 over 3, and that gives us negative 23 over 3. So for the sake of time, I'm just going to use the shorter method of dividing both sides by the coefficient of my x value. So that is going to be dividing both sides by the fraction in front of x, or by 23 over 4. So on your calculator, you can put negative 23 over 3 divided by 23 over 4. What I would recommend, in order to reduce the chances of error, on your calculator, type it in like this: negative 23 over 3 divided by 23 over 24. Don't use fraction over fraction method, because that increases your chances of error if you are not familiar on how to put a fraction over a fraction. So if you are not familiar, or if you doubt yourself, use the fraction symbol instead of the fraction over fraction, okay? So negative 23 over 3 divided by 23 over 24, and that gives us a value of negative 8. I'll show you how to check if your answer is correct once we've obtained both x and y. So x value was obtained as negative 8. Now to get our y value. So to get your y value, you can choose either equation. It does not matter which. So I'm just going to go with the one that has less fractions, which is the right-hand side. So in place of x, I'm going to put negative 8. And that is then going to give me a y value of negative 3 minus 3, which is going to be negative 6. You can also put that into your calculator to confirm. Doesn't matter which formula you used. Even if you used 4 over 3x plus 14 over 3, you would have ended up at the same answer. Okay, I just chose to use that one. So let us conclude. So we can conclude that the coordinates of D are negative 8 and negative 6. Now let us check if our answer is correct. We can't confirm the exact value of coordinates D just by the method that I'm about to show you, but we can determine if our answer feels correct. Okay, so as you can see, we've obtained the coordinates of negative 8 and negative 6. What that means is that our answer must be in the third quadrant. So our point D needs to be over there, because this is the only quadrant whereby we have a negative x value and a negative y value. In quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, both x and y are negative. And in quadrant 4, x is positive, y is negative. So based on your quadrants, you can basically determine if your answer feels correct or if it is correct, but you will not be able to determine if the actual values are correct. So for example, if the actual answer was negative 10 and negative 20, and we have negative 8 and negative 6, because the negatives are in place, because it's in the correct quadrant, it can feel correct, but we won't be able to determine the exact value of whether it is correct or not. Another way to determine if our answers are correct is to substitute the x value into both equations. If you substitute the x value into both equations and it gives you the exact same y value, that is also an indication that your answer is correct. Okay, so if we go to our graph, you can see that our point D is in fact in the fourth quadrant. And I'm assuming that our answer is correct, because if you notice, C is at negative 3. Our y value for D was at negative 6, I believe. So you can see that D's y value is lower than C, so it will be a smaller y value. Just allow me a moment to check the chats to see if there's any questions before we proceed. Okay, so let us proceed. There aren't any questions. Excuse me. Okay, so our next question, we just completed 3.5. So our next question is 3.6. We need to prove that ABCD is a parallelogram. So what I would recommend, if you do not know the properties of your shapes, go to your textbook. I'm sure there's a section there that that references properties of shapes or properties of quadrilaterals. So go to your contents page. That's the page at the beginning of your textbook. Sometimes it's called an index, whereby it lists the topics and their page numbers. If those, then find wherever it says properties of shapes or properties of quadrilaterals. If it's not in the grade 11 textbook, I know for a fact that it is in the grade 10 textbook. So if you don't find it in your grade 11 textbook, I would recommend you have a look at a grade 10 textbook, or if you have a friend or sibling that's in grade 10, you can ask them to borrow a textbook if you do not have one. Learn those properties. For analytical geometry, those properties are very important. If you do not know the properties of a parallelogram, you would not be able to answer question 3.6. So our question was to show or to prove that ABCD is a parallelogram. So let me highlight ABCD. So A, B, C, D. So one method of proving something is a parallelogram is to prove that opposite sides are parallel. So if AD is parallel to BC and AB is parallel to CD, that is a parallelogram. Alternatively, you can prove that opposite sides are equal, meaning that if AD is equal to BC and AB is equal to CD, then that would be a parallelogram. You don't have to prove all the properties. You just have to prove one of them. So because we already dealt with parallel lines, I'm going to use the parallel lines property. So let's look at AB. Because we've already, something important to take note of, because they've already given you, or because they've already stated that AD is parallel to BC, don't just go repeat it. It's already given in the equation, or the question, sorry. I would recommend you go and prove that AB is parallel to DC. Okay. That will show opposite sides parallel. Instead of going and repeating, going and showing AD parallel to BC, because it's already stated, so you're just doing extra work for nothing. So let us go and prove that AB is parallel to CD. And this is question 3.5. So we need to find the gradient of AB equal to y2 minus y1 over x2 minus x1. Now the coordinates of A are -2 and 2. The coordinates of B, allow me a moment to confirm. B is 6 and 5. So I'm going to make A my 1 values, so x1, y1. I'm going to make B my 2 values, so x2, y2. Now from here, all I'm going to do is I'm going to substitute into the equation. So the gradient, because we're finding the gradient of line AB, my subscript will be AB. Y2 is 5 minus y1, which is 2 over x2, which is 6 minus x1, which is -2. Please don't leave out the negative from the 2 because you already see a negative sign there. So once you substitute your values, you don't need to find the top separately, the bottom separately. It's just easier to put the entire thing onto your calculator and you can get the value. So that is therefore going to be 3/8. Now, let us go and find the gradient of the opposite side. Now, we found AB. We now need to find the gradient CD. Now, there's two approaches that we can take. The first approach is to use the equation of the line CD because we were already given the equation, right? So all we need to do is subtract the M value. Alternatively, what we can do is calculate using the formula that we just used to find CD using their coordinates. So for the sake of time, I'm going to use the shorter method. We were given CD as 3/8x minus 3. So 3/8x minus 3. So y of CD was 3/8x minus 3. Keep in mind that the formula of this equation is y equals mx plus c. So as you can see, m is 3/8. So the gradient of CD is equal to 3/8. Let me just move this to the side so I have some space at the bottom. So we can therefore conclude that the gradient of AB is equal to the gradient of CD, which then means that the line AB is parallel to CD because their gradients are equal, which then means that therefore ABCD is a parallelogram. Okay. An alternative approach that you could have taken is to calculate the distance or the lengths of the opposite sides. If the lengths of the opposite sides were equal, then you could have concluded that that is in fact a parallelogram. But for this particular question, all we did was we calculated the gradients of the two opposite sides because we already knew that the previous two lines, let me just confirm the names of those lines. So we previously, or not confirmed, but it was stated by the question that AD is parallel to BC. So we didn't need to go and recalculate or reconfirm or reprove that because it's already given. All we now needed to do was prove that AB is parallel to CD, and we've done that. For AD, because we didn't know the equation of AB, I used the gradient formula that you are used to. For DC, you could have also went and used the gradient formula whereby you use coordinates C and D, but for the sake of time, I chose to extract my gradient from my equation of a line. So before we move on to question 3.6, does anyone have a question? You're welcome to unmute yourself and speak up.
Hi, sir.
Yes.
Yes, for the gradient of CD, we can also use the formula y2 is equals to y1 over x2 minus x1. Or we must automatically use the mx plus c.
That is correct. You can use y2 minus y1 equals, y2 minus y1 over x2 minus x1. it is 100% correct to use that formula. You will not be penalized. You will not be marked incorrect. You can use that formula. For the sake of time, I just chose to use another formula, which is the straight line one, and extract my value. In addition to that, I felt like because I already used the formula method, I wanted to show you an alternative method, so you had both options to choose from. Does it make sense?
Yes, does. Thank you.
Does anyone else have a question? Okay, so let us proceed then. So our last question of this exam paper, or rather of this particular question 3, is calculate the coordinates of M. So let us go and find M. Okay, so M, if you do not know the properties of a parallelogram, you will be stuck on M. If you notice, M is the intersection of both the diagonals. M is your point of intersection of BD and AC, which are the diagonals of your parallelogram. And one of the properties of a parallelogram is that the diagonals, the point where they intersect, that is the midpoint of both diagonals. So M is the midpoint of AC, and M is also the midpoint of BD. So you can use your midpoint formula, which is the second formula on the formula sheet I gave you, and you can use that formula with AC or with BD, but you cannot use it with AD, BC, AB, or CD. It has to be the lines of your diagonal, the endpoint specifically. So I'm going to use AC and refer to M as my midpoint because those 2 points are given. We also have D, but because I can clearly see those, I'm just going to use those ones. You can also use BD if you want to. You'll get the same answer. So I'm going to use A, which has coordinates -2 and 2, and C, which has coordinates 0 and -3. So this is question 3.6. So it's very important when dealing with analytical geometry to know your properties of a line. Okay. Okay. So we now have question 3.6, I believe. Just give me a moment. Okay, so question 3.6. Why is this not writing? Just give me a moment, please. Okay, so question 3.6. We are going to assume, or not assume, because we know the properties of a parallelogram, we are going to state M is the midpoint of AD, or I believe it was AC, of AC and BD. So you can use whichever coordinates you want to. That's completely up to you. You can either use A and C, or you can use B and D. For this particular question, I'm going to go with A, which is -2 and 2, and D, which is 0 and, sorry, C, not D, which is 0 and -3. So this is going to be my x1, y1, x2, y2. Okay. So the formula is M into, you don't put an equal sign because remember when you're writing your coordinate is the letter a bracket. There's no equal sign in between. So x1 plus x2 all over 2 into y1 plus y2 all over 2. From there, we substitute x1, which is -2, plus x2, which is 0, all over 2, and then y1, which is 2, plus y2, which is -3, all over 2. From there, we can put each part into our bracket, into our calculator rather. So -2 plus 0 all over 2, that is going to give us -1. And 2 plus -3 is going to give us -1 over 2. So that is the coordinates of M. It is -1 and -1 over 2, or you can refer to it as -1/2. Excuse me. Now, something that I've seen that pops up quite frequently is if you are given the midpoint of a line and one of the endpoints are unknown. So I want us to try and have a look at that using the line BD. So if you look at BD, right, we've already stated that, or we've already determined the coordinate of M, which was, I believe, -1 and -1/2. And we have the coordinate of B, but we do not have the coordinate of D. I mean, I know we calculated it previously in one of the previous questions, but let's assume that right now we don't have it. So how would we calculate the coordinate of D using our midpoint? Okay, so let us try and determine the coordinate of D using the midpoint formula, and let us see if the value of D using our midpoint formula is the same value of D that we previously got. That'll be confirmation that our previous answer of D was also, or was in fact, correct. So just make a note that this is not part of the question. So we have this line. So this is our coordinate D. This is our coordinate M, which has -1 and -1/2. And this is our point B, which had coordinates. Let us just go and investigate or double check. So B had coordinates 6 and 5. So B had coordinates 6 and 5. Now, how do we find the coordinates of D, taking into consideration M as the midpoint? So let's just make a note. This is midpoint. So all we would need to do is write out our midpoint formula. And then because we have the coordinates of our midpoint, what we are going to do is break up this formula into the X and Y components. So we'll break this up into the X component. Which is M of X equals X1 plus X2 over 2. Now, m of x basically represents the x value of m. So we're going to separate the formulas and then break this up into the y component, which will then be m of y, which represents the y component of your midpoint, or the y value of your midpoint, equals y1 plus y2 all over 2. So all we did is separate the formulas. Okay. Now, from here, I'm going to start with the x side. So that is then going to be m of x, so my x value of m, which is -1, equals x1. Let's make b x1. So that's going to be 6 plus. Now, x2, let's make it d. Because I don't know d, I'm just going to call it xd to represent the x value of d. So as you can now see, we only have one unknown, which is the x value of d. So from here, we'd cross multiply. That'll give us -2 equals 6 plus xd. From here, we can move 6 to the other side, giving us -2 minus 6 equals xd. From there, we can conclude that xd equals -8. So that is the x value of d. Now let us have a look at the y value of d. So the y value of m is -1 over 2. And the y value of b is 5, I believe. Let us just confirm. Yes, it is 5. Plus my y value of d, I'm just going to call it yd, all over 2. From here, I'm going to cross multiply, which will leave me with -1 equals 5 plus yd. From here, I can move 5 to the other side, leaving me with -1 minus 5 equals yd. So that'll then conclude that the y value of d is -6. So we have the coordinates of d as -8 and -6. Now let us go back to the previous question and see if it's the same, -8 and -6. As you can see, we previously proved that the y, or rather that the coordinates of d are -8 and -6. So that means our coordinates of d are correct. And as you can see, this is an alternative method or an alternative way of using your midpoint formula. So that is the last question of question 3. Before we proceed to question 4, does anyone have any questions of their own? Any parts that they did not understand? Anything I need to repeat, re-explain? You can speak up now. Let me zoom out so you can see what we've done to determine whether you are confused about any of the parts. So this is basically what we've done. Yes, the student that has your hand up. Tyler, do you have a question?
Yes, sir. From where we started the midpoint side, the last question basically, there was a part where, can you please zoom in? I just want to. Yes.
The last midpoint part.
Yes.
The stuff I did in red and green.
Yes. Why did you break it apart? Why isn't you couldn't just substituted the values of x and y, x1 and y1, x2 and y2 into the midpoint formula, then giving you -1 is to -2? Why you did it that way, or is my way of saying it, of doing it, incorrect, or it applies in different questions?
So you mean doing it like this? Just give me a moment. 6 plus D.
Or is it the coordinates that I used? Because I used A and C.
Yeah, if you use A and C to find M, it's absolutely correct. Remember, I just chose to use B and D because I wanted to, remember there were two options. You could have used BD or AC. I just chose to use BD. Okay, but back to your original question. Is this what you meant when you said keep it together?
Yes.
Yeah, this is absolutely fine. The reason that I separated it is because students that are not familiar with this method or students that struggle with these things, it's more difficult for them to do it simultaneously or to calculate X and Y simultaneously. So to separate it is easier for them. So I prefer to use that method to make so it's easier for students to understand. But if you prefer to use this, it's absolutely correct. Do what works for you. If I did something that you have an easier method or method that you prefer to use, by all means proceed with that. This is just one of the ways you can do it. Does it make sense?
Looking at what you have written, you said 6 plus dx. Don't we have the coordinates of dx and
Yes,
dy?
we have the coordinates of D. Remember, I did this to show you how to use the midpoint theorem if you don't have one of the endpoints. This question that I did here was not from the question paper. It's something that I wanted to show students in case it pops up.
Oh, okay, that's the part I missed out. Because yes, I see you have the answer there. Midpoint is -1:2. So we won't be marked for the x component and the y component written in red and green.
No, remember, you won't be marked for this because this is not part of the question. This was something additional that I did because I saw, like when I was going through past papers, I saw that this pops up sometimes whereby they give you the midpoint and they give you one of the endpoints. So you were then asked to calculate one of the other endpoint that's not given using midpoint formula. And a lot of students struggle with this concept. So that is why I included it. And I also included it as a way to prove that our coordinates of D that we previously calculated are in fact correct.
Yes. And then last question, I'm so sorry. How would you identify in an exam paper this type of question?
Okay, so yes, you're saying?
That needs this further solving, if I may say.
Okay, so in an exam paper, if it's stated that M is the midpoint, keep in mind that they won't always use M to represent midpoint. They can use any letter, it doesn't matter. You need to be able to identify that that particular point is a midpoint. So if they tell you that that particular point, in this case, M is a midpoint, and they give you the coordinates of B, for example, but you do not have the coordinates of D. So this is one of the methods that you could have used. So in the previous question whereby we calculated D, if we were previously told that M is the midpoint and we were previously given the coordinates of M, we could have easily used this method instead of using the simultaneous equation method of joining the two equations of a line. Does it make sense?
Yes, very much. Thank you so much.
Okay, perfect. Anyone else with a question before we move on? Okay, I see there is one. Yes.
So if they're asking us to calculate the midpoint, so we use this formula. There's no other formula that we can use.
If you want to calculate midpoint, you'll use this formula on top.
Hello?
Yes, are you able to hear me? Hello? Are you able to hear me now?
Hello, sir. Yes.
Okay, so if you were asked to calculate the midpoint coordinates, you will use the formula in 3.6. Keep in mind the thing that I did at the bottom, that calculation in green and red, that is an additional question that I thought would be interesting for students to be able to understand how to attempt it. So if you want to calculate the midpoint coordinates, use the formula that I gave you in the formula sheet, which is the second formula, and is the formula you see in 3.6. Does it make sense?
Yes. Yes, it does. Thanks.
Okay, so all you do is you add up the x and y values divided by 2. Add up both the x values divided by 2. Add up both the y values divided by 2. That'll give you your coordinates of your midpoint. So there was one more question in the chats. Just give me a moment. I do not understand the concept of why we use simultaneous equations. Okay, so the whole concept of why we used simultaneous equations was because keep in mind that simultaneous equations refer to something whereby both the x and y values are the same. That is when we can use simultaneous equations. Now, if you look at point D, you can see that point D is a point of intersection or a common point between AD and CD. So because D is a common point or point of intersection of AD and CD, it then states that whether you use DC or AD, you will end up with the same X and Y values for point D because that single point D is on both equations. That allows us to calculate simultaneous equations. Samira, does it make sense? Then I see there's a hand up. Liema, do you have a question? Yes, and the other student that said so.
Sir, please repeat the question when you calculated the coordinates of D simultaneously.
Okay, so the question whereby I calculated the coordinates of D, because I was given the equation of AD and CD, I was then able to connect those equations based on the fact that because D is a common point on both equations, on both lines, it then means that this y values are equal. So I can just basically put them next to each other with an equal sign in the middle. I'm connecting them because those D values are going to be the same, or those y values are going to be the same. So all I need to do is plug both equations together. Keep in mind, this is very important. Even when you are doing functions, I'm sure you've come across functions whereby there's a point of intersection. This concept of a point of intersection comes about in functions, it comes about in analytical geometry, and it comes about in trig functions. Trig, your sine graph, your cos graph, your tangent, your tan graph. So this concept appears in all three topics. And next year when you start calculus, you'll find it as well. So what this means is that because D is a common point on both lines, you can therefore use simultaneous equations to connect those two lines based on the common point. So it's a point of intersection. Because they're intersecting, it means at that particular point, they have the same value. So we can equate them. Because they're equal, they have the same value. Does it make sense?
Yes, it does.
Yes, sir.
Okay. Okay, so there was a lot of sirs that I heard. Let's do this. Liemo, did I answer your question? I think you were the person that was discussing the simultaneous thing, right? So
yes, I understood it.
Okay, perfect. So you're done. Then Toki, sorry if I mispronounced your name. You had a question?
Yes, sir, I had a question. I regarding the simultaneous equations. So when we are calculating simultaneous equation, we will be always be given the equations. Like for instance, DC, we were given that DC is equal to 3 over 8x minus 3.
Wait, please repeat your question.
So my question is that when using simultaneous equation, we will be always given the equations that we must use in order to find the coordinates.
Okay, so sometimes you might not be given both equations, but maybe you calculated the equation in a previous question. So by the time you get to that point, like the question that we did, I think we were given one and we calculated another. Yeah, AD, we calculated AD in 3.3, I think. Let me just confirm. Excuse me. Okay, no, we calculated AD in 3.2. So we weren't given both equations, but we previously calculated one of them.
Yes.
So we calculated AD in 3.2 and we were given DC. But once you reach that point, you should have both equations. Yep, the next question.
Yes, sir, I understand you.
Oh, okay, perfect. Okay, then I saw there was someone in the group that said, can you please go back to the point where you were proving ABCD is a parallelogram? I didn't understand. Okay, the student that's got like a smiley face and a heart at the end of your name in the group. This is the question whereby we did that. Just give me a moment. Okay, here. So for that particular question, 3.5, we needed to prove that this is a parallelogram. So basically, what needs to be done is, because it is a parallelogram, or in general, whenever you are doing such questions, you need to understand and know your properties of shapes. If you do not know your properties of shapes, you would not be able to answer such a question. So if you did not know your properties of shapes, you would have been stuck on this question as well as the midpoint question, because you would not have known the intersections of the intersection of the diagonals of a parallelogram is the midpoint of those diagonals. So when we are proving that something or that a quadrilateral is a parallelogram, we have two approaches. The first approach is to prove that opposite sides are parallel, meaning that AB is parallel to CD and the other one was AD is parallel to BC. Now, because the question already stated, it was already in the question that AD is parallel to CD, we did not need to go and restate it. It was already there. It's like if your teacher asks you a question in class, what is 1 + 1? And your friend said 2. And then you go and put your hand up and you also say 2. The question was already answered. You don't need to re-answer it. So it was already stated in that particular question that those two lines are parallel. We used that property in the first question, 3.1. So we did not need to go and restate it. So all we needed to do was show that AB is parallel to CD. And based on the question, they've already stated the other two lines were parallel. Therefore, we proved that this is a parallelogram. Now, the second option that you could have used, which I did not use, because you don't need to use all the properties to prove. You just need to use one property, okay, unless stated otherwise. So the second option to take is to prove that opposite sides are equal. If you calculated the distance of AB and the distance of CD, and you found that those two distances were equal to one another, then that proves that it is a parallelogram. Okay. Now, the concept of the equation whereby I extracted my gradient value, you do not need to take that approach. I took that approach for the sake of time and for the sake of giving you an alternative option of calculating gradient. because there are multiple ways of calculating gradient, it's important for you to be able to use and understand all those different ways. So if you look at the second option that I've taken, that's boxed in green, that option is to extract gradient from the formula. You did this in grade 8. So all you do is where that value that represents gradient, the coefficient of x, always remember the coefficient of x represents your gradient. All I did was to extract that value instead of recalculating using my gradient formula. It's just time consuming to have to go and reuse the gradient formula, substitute values. It's easier and it takes less time to just extract a value. Then I saw there was another hand that was up. The student that had your hand up before I started explaining the properties. What was your question? Can you please go back to, okay, I believe this question was answered, the one that was in the chats. Tobeka, I assume that you are the smiley face heart person. Okay. So that is basically it for question 3. Let us go to question 4 and see how long it is, because we have about 18 minutes left. And like I mentioned previously, it's unrealistic to expect us to complete an entire year's syllabus in a 2-hour class. Okay, you see your teacher, what, almost 10 hours a day, 5 days a week to complete the year's syllabus. So in today's class, it was just a way to assist you with areas that you struggle with. Okay, like we only completed 1 question in that entire time. So yeah. Okay, so let's look at question 4. Okay, let's see if I can finish question 4 quickly.
Your connectivity sir, is not picking up.
Are you able to hear me now? Hello? Hello? Tyler, you mentioned the connectivity is bad. Are you able to now hear me? Okay, how many people can hear me clearly and see my whiteboard? If you can indicate with a thumbs up so I know we can proceed. Okay, so it seems like most people are able to see it. Okay, so let me proceed then. Yeah, okay, so we have in the diagram F, which has coordinates 2 and -2, G, which has coordinates 5 and 2, and C, which has coordinates 6 and Y. So as you can see, the Y value of C is not given. Are the vertices of triangle FGC. FG is perpendicular to FC. So because FG is perpendicular to FC, the product of their gradients is going to be equal to -1. Then it states N is a point on FG such that the inclination of NC is 104,04 degrees. Always remember that whenever you are dealing with angles in analytical geometry, your angle must always start from your horizontal. You can't have an angle that's starting from an inclined position. For example, if this is your line, you can't now go and draw an inclined horizontal and make that your angle. That doesn't work. Whenever you are dealing with an angle, always create an x-axis. This is known as your horizontal, an x-axis, okay? It doesn't matter whether your x-axis is here or here or here. As long as it is a horizontal x-axis or a horizontal line, that indicates a, what you call this thing? A horizontal. That's what you need. You only need a horizontal. Okay, just give me a moment. I see there's a message in the chats. Okay, Tyler, you mentioned the connectivity is bad. Most students said yes, they are able to hear me. So I think maybe it could be your side if a lot of students are able to hear me.
No, it's sorted out. Thank you.
Okay, cool. Okay, let us proceed. So our last statement states the angle of inclination of FG is beta and FNC is equal to theta. So as you can see, we are dealing with three different angles. We have the angle of 104.04, we have the angle of theta, and we have the angle of beta. And if you look, point F is an angle of 90 degrees because those two lines are perpendicular to one another. Now, 4.1, calculate the gradient of FG. So if you were to calculate the gradient of FG, that is something that we've already done. But if you take note of FG, let me highlight it for you. We have the coordinates of F, we have the coordinates of G. So it's exactly the same as what we've been doing the whole time. There's no difference. All we need to do is put in our formula, excuse me, put in our formula, substitute the given values, and that'll give us our coordinates of, or rather our gradient of FG. So our formula is m equals y2 minus y1 over x2 minus x1. Now, what coordinates are we using? We have two coordinates on the line FG. Just give me a moment to double check if I am using the correct line. They said FG. Yes, I am using the correct line. Okay, so calculate the gradient of the line FG. So my coordinates of F are given as 2 and negative 2. My coordinates of G are given as 5 and 2. So I'm going to make F my 1 values and G my 2 values. So let's substitute. Because it's the gradient of FG, I'm going to use the subscript FG is equal to Y2. Now Y2 I've stated as 2. Then y1 I've stated as negative 2 over, now x2 is given as 5 and x1 is given as 2. Now, if we continue, we've got FG equals. Now, all we need to do from this point is put this into our calculator. So we've got 4 over 3. Okay. Let me just double check that on a calculator. Yeah, it is correct. So 4 over 3. Our gradient for this particular question is 4 over 3. Something interesting to take note of, our previous 3.1 was also 4 over 3. Okay. So let us proceed. Now, we have question 4.2 that states, calculate the value of y. Now let us go, okay, here's our value of y. I've highlighted it in yellow. So our value of y, we need to find that value of y. Now we have point C, which has an x value of 6 and a y value that we do not know. Let us see, how can we find the value y? Something important to take note of, if you remember from the information given above, they stated that FG is perpendicular to FC. So what does that mean? It then means that the gradient of FG times the gradient of FC is equal to -1 because those two lines are perpendicular to one another. And if you notice, C is a point on the line FC. So we can use our properties of gradients to calculate the coordinate FC. So let us first calculate the gradient of FC. Once we find the gradient of FC, we will use that gradient to calculate the value y. So question 4.2, we have the gradient of FG times the gradient of FC is equal to -1 because FG is perpendicular to FC. Now, our gradient FG is what we just calculated in the previous question times the gradient FC equals -1. Now, all we now need to do is divide both sides by 4/3. So we have -1 divided by 4/3. And that gives us -3/4. Now that is the gradient of FC. Okay, now we are going to use this gradient of FC to calculate the y value of C. So let us first get our coordinates that we are going to use. Remember, when we calculate gradient, we use two coordinates. So in this case, we're going to use the coordinates of F, which is 2 and -2, and the coordinates of C, which is 6 and y. This is going to be my x1, this is going to be my y1, this is going to be my x2, this is going to be my y2. Now, from this point, we are now going to substitute. Let's first write out our formula before we actually substitute. So the gradient of FC is equal to y2 minus y1 over x2 minus x1. Now we already calculated the gradient of FC. So all we do is we substitute. So that is going to be -3/4 in place of the gradient of FC. From there, we can substitute our x1, x2, y1 values. The only value that we will not substitute is y2 because we don't know that value. So y2 is y minus y1 is given as -2 over x2 is given as 6 minus x1 is given as 2. Now from here, let us simplify. So we've got -3/4 equals y plus 2 all over 6 minus 2, which is 4. Okay, now from here, I'm going to multiply the 4 in my denominator with the left-hand side. So it's a concept of cross multiplying. I'm just going to restrict it to one side. I'm not going to do the full cross multiplication. Actually not, for the sake of understanding, it is a bit of a longer method, so I'll just do the full cross multiplying. So we cross multiply, it's going to be the 4 from the right, multiplying with the -3 from the left, equals the 4 from the left, cross multiplying with the y plus 2 on the right. From this point, we've got -12 equals 4y plus 8. From here, we can move that +8 to the left to become -8 equals 4y. From here, we have -20 equals 4y, and y is therefore equal to -5. Once we divide both sides by 4, that is our answer. So that is how we found the value of y, which is the y coordinate or the y value of the point C. Because we knew that those two lines were perpendicular to one another, I used that property to find the gradient of FC. Once I found the gradient of FC, I did the normal things that we are used to, which is put in my formula, substitute what is given or what is known, and solve for the unknown. Okay, so before we proceed, Is anyone confused with what I've done in 4.2? Does anyone have any questions, anything they'd like to ask? Are we going to have a next lesson? 7506 and so on. Yeah, we will have, and Patrice, we will have a next lesson. Keep in mind, I think our next lesson is physics for those that do physics. For those that don't do physics and only do math, yeah, there will be a next lesson. An announcement will be made in the group. Okay, can you please repeat the question? Okay, so our question was to calculate the value of y. So we needed to now calculate this value of y. As you can see, y is the y value of point C. And if you notice, F is at a 90-degree angle. So that means, and it was previously stated, that GF is perpendicular to FC. So all I did was I used my properties of perpendicular lines, which states that when two lines are perpendicular to one another, you can calculate the gradient of one of the lines by finding, or by using the formula, the product of the two lines is equal to -1. As you can see from step or line 1, I multiplied the two gradients, made it equal to -1. From that point, I already knew the gradient of FG because we calculated it in the previous question. And that allowed me to find the gradient of FC based on the fact that those two lines are perpendicular to one another. Once I found the gradient of FC, we did the reverse of what we normally do. So normally we don't have the gradient and we substitute the x and y values and we obtain the gradient. But in this particular case, we did not have one of the y values, but we had gradient. So all I did was I substituted gradient that I previously calculated based on my perpendicular properties, and I substituted the two x values and the one y value that I knew or that was given. From there, all I did was I solved for excuse me. From there, all I did was I solved for y. Okay. Yeah. Inam, does that answer your question, or do I need to explain it in a different way? Okay, so it is already 7, so we'll end here for today. What I'll do is I will take a screenshot of the question that was left incomplete. I believe there is 4.3 and 4.4 left of that question. So what I'll do is I will share the screenshot in the group. You guys can calculate it or solve it on your own and share your solutions or what part you're struggling with in the group.